In this video, we'll take a look at some triangle basics. A triangle is a polygon with 3 sides. A triangle with 3 vertices, A, B, C, is written as triangle ABC. We name a triangle with their vertices. We have some triangles that you can classify by the value of the sides. So a scalene triangle, here's an example, has no congruent sides. An isosceles triangle has at least 2 congruent sides indicated by the markings here. And an equilateral triangle has 3 congruent sides. You can also classify triangles by the angles. An acute triangle has 3 acute sides, 3 acute angles. A right triangle has 1 right angle indicated by that right angle marker. An obtuse triangle has 1 obtuse angle, this one here. And an equiangular triangle has 3 congruent angles. There are also interior and exterior angles. Interior angles are those angles on the inside of a triangle. Exterior angles are formed when the lines of the triangle are extended, and the angles are therefore on the outside. Can you name the interior angles and the exterior angles on this example? Go ahead and pause your video and try. The interior angles are angle 1, 2, and 3. The exterior angles are 4, 5, 6, 7, 8, and 9. We have a triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. So we're given that we have a triangle A, B, and C, and we want to prove that the measure of angle 1 plus the measure of angle 2 and the measure of angle 3 will add up to 180. Statement number 1 says draw a line BD parallel to AC. So we have this and this line being parallel. That's using the parallel postulate. Angle 4, which is an exterior angle, plus the measure of angle 2 and the measure of angle 5 have to add up to 180 using the angle addition postulate and the definition of a straight angle. Angle 1 is angle 1 is congruent to angle 4. Angle 3 is congruent to angle 5 using the alternate interior angle theorem. So if this is your transversal, 1 and 4 are alternate interior angles. 3 with 5 if this is your transversal. Going from angles being congruent to their measures being equal is your definition of congruent angles. And therefore, we can substitute angle 1, 2, and 3 in to say they add up to 180. So this is that connection between line 2 and line 5. We're keeping the measure of angle 2 the same. We're able to substitute the measure of angle 1 for the measure of angle 4 here. And the same thing here. 3 and 5 are equal, so we can replace this statement of 5 with 3 using the substitution property of equality. Now we know triangles have to add up to 180. So if you know that theorem, you should be able to find the value of x and classify the triangle. We know all 3 have to add up to 180. So if we solve our equation, x should equal 35. And when I try to classify that triangle, if I'm looking at the angles, I can see that I have an obtuse angle. So this could be an obtuse triangle based on the angles given. We also have the corollary to the triangle sum theorem. A corollary to a theorem is just a statement that can be proved easily using the theorem that we already know. The acute angles of a right triangle are complementary. This is that corollary to the triangle sum theorem. So if we know that angle 3 is 90 degrees, and we know all the angles within a triangle have to add up to 180, if we do 180 minus the 90 degrees, we'll have 90 degrees left over to share between angle 1 and 2. Therefore, the measure of angle 1 plus the measure of angle 2 will equal 90 degrees, which makes them complementary. And you have the proof here as well. Find the value of x and classify the triangle. So if I know this is a right angle and it's 90 degrees, I have 90 degrees left over for these other two angles. They're the same measure, so x must equal 45 degrees. Find the measure of angle A and angle C. Again, we know this is 90. So the measure of A plus the measure of C will also equal 90. So we'll go ahead and add these two angles together and set it equal to 90 degrees. And you can solve to find your variable. And in this case, your variable equals 12. You also have to then find the measure of both A and C. So we're replacing 12 in each expression. So the measure of angle A will equal 47. And the measure of angle C will equal 43. Our first one, it also asked us to classify the triangle. Because these two angles are the same, we have isosceles triangle. They're also right triangle because we have 90 degrees here. We also have the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measure of the two non-adjacent interior angles. So to think about that, angle 1 and angle 2 make a linear pair, so they have to add up to 180. But we know the angles within a triangle also have to add up to 180. So if I said the measure of angle 1 plus the measure of angle 2, that's going to equal the same thing as the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. If I do some substitution or subtraction property, subtracting the measure of angle 2, I'll see that 1 equals the measure of angle 3 plus the measure of angle 4. You have a paragraph proof to explain that. Using the exterior angle theorem, find the value of y. Well, again, y will equal the sum of the non-adjacent interior angles. So y should equal 158 degrees. Find the measure of angle 1 and B. So we know the measure of angle 1 will equal to the sum of angle B and A. So 5x minus 2 equals 76 plus 2x. I'm going to subtract 2x on both sides. I'm going to add 2 to both sides. Then you can go ahead and solve that one-step equation. 78 divided by 3 will give us an x value of 26. And we have to go ahead and substitute that into our expression for angle 1. So 5 times 26 minus 2 will give us the measure of angle 1. And that'll equal 128 degrees. We also have to substitute in our value of x for measure of angle B. 2 times 26 will be 52 degrees. Here's another example for you to try. Definitely pause the video and see what you can figure out for yourself. Unpause and see what else we have. I'm going to start off with my little triangle here. I know the sum of all the angles within a triangle have to add up to 180. So I'm going to say the measure of angle 1 plus 45 plus 65 will equal 180. So as I go ahead and subtract 65 and 45 from 180, I'll get the measure of angle 1 to be 70 degrees. So that's going in here. That's 70 degrees. I know the measure of angle 1 plus my little wedge of 45 and 2 have to add up to 180. So I'll say the measure of angle 2 plus the measure of angle 1, which was 70 degrees, and that little wedge of 45 will also equal 180 because they make that linear connection there. So we have 180 minus 45 and 70. That'll give the measure of angle 2 to be 65 degrees. So if I know this one's 65 degrees, 65 and 20 plus the measure of angle 3, so 65 plus 20 plus the measure of angle 3 have to also add up to 180 degrees. The measure of angle 3 will equal 95 degrees. We also have triangle congruence. If in two figures, all the corresponding parts are congruent. This is the corresponding parts of congruent triangles are congruent statements. And we abbreviate that with the acronym, or not the acronym, but the letters CPCTC, representing corresponding parts of congruent triangles are congruent. In polygons, this means corresponding sides and angles are congruent. We have to be very careful about how we name a triangle, and when we name a triangle and compare it to another, we should be listing the triangle in the same order. Therefore, angles will be listed in congruent pairs, and sides will be congruent. So for example, here I have all these markings, so I can see angle A has 1 arc, so does angle F. Angle B has 2, E has 2, C has 3, and D has 3. Therefore, when I name it and make that comparison of congruence, I'm saying the triangle ABC is congruent to FED. I can't name it in a different order because I'm listing the angles congruent to themselves. Also, I can also represent corresponding sides, which are going to be congruent as well. We can say that AB is congruent to FE, BC is congruent to ED, AC is congruent to FD. And the way I order my triangle, if I say triangle ABC, I'm telling you that AB is congruent to FE. And that, let me switch to a different color, BC is congruent to ED. And this is a little weird connection, but CA is congruent to DF. I have to name it in the order that my triangle lists its congruent sides and angles. We have a third angle congruence theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angle will be congruent to the third angle in the second triangle. We also have properties of congruent triangles. We have that reflexive property for any triangle ABC. Triangle ABC will be congruent to triangle ABC. We have the symmetric property. If triangle ABC is congruent to DEF, then triangle DEF is congruent to ABC, as well as the transitive property of congruent triangles. If ABC congruent to triangle DEF and triangle DEF congruent to triangle JKL, then triangle ABC will be congruent to triangle JKL. Example, identify all of the congruent parts. So that includes angles, sides, and then let's see what kind of conclusion we have. Go ahead and pause the video. Angle K is congruent to angle S. Angle L is congruent to angle R. Angle J is congruent to angle T. Be careful naming your sides. You want to go from angle to angle. So if I go from K to L, I'm going from one arc to two arcs. Over here, I have to do the same, S to R. And in that order, I went from one angle marking to two angle markings. If I then go from angle L to angle J, that's the same as side R to side T. And lastly, J to K, T to S. Conclusion, triangle KLJ is congruent to SRT. It may seem silly that we have to name the triangle in a certain order, but we're doing that so you can tell just by the name of it what parts are congruent. Given triangle ABC is congruent to DEF, find X and Y. So you might want to start by marking the angles congruent. I know that angle A is going to be congruent to angle D based on the naming. So I can go ahead and set those angles congruent to each other or equal in measure. 22 is equal to 5y minus 3. And solve that equation. We'll get y equals 5. Angle B is congruent to angle E. Angle C is congruent to angle F. Now when I go through the sides, I can see I have a measurement for AC that goes from 1 arc to 3. That's corresponding to DF. So these, because they're corresponding parts of congruent triangles, the parts will be congruent. So I can say 9 equals 3x and solve. I'll get x equals 3. And we started off just simply by looking at the way they named the triangles. Then I can identify the parts because we don't know anything about these angles. These images are not drawn to scale, so you have to use the information given. Find the value of x. Well, here's x. So a couple of things we know. We know this angle marked is congruent to this angle. We should also know something about vertical angles. So it's not marked, but we do know vertical angles are always congruent to each other. Therefore, the third angle will be congruent to the third angle in this triangle. Therefore, x is equal to 65 degrees. Third angle congruence theorem. Okay, let's take a look here. We have one angle congruent to another, second angle congruent to this angle, therefore the third angle will have to be congruent. We're finding the value of x, so 55 equals 5, parentheses 3x plus 5. We have to go ahead and solve that equation. I'm going to divide by 5 on both sides. Subtract 5. And divide by 3, we'll get our x value to be 2. We have a proof. Given the figure at the right, prove triangle ACD is congruent to CAB. So we have one side congruent to this side, second side congruent to that side, and obviously the third side is congruent to itself. So we can go ahead and mark that. I have one angle congruent to this angle, second angle congruent to the second angle, therefore the third angle will be congruent to the third angle here. So let's see all about that. We've got AD congruent to CB, DC congruent to BA. We know that AC is congruent to itself, and that's using your reflexive property of congruence. We are told angle ACD is congruent to CAB, and CAD is congruent to ACB. Therefore, angle B is congruent to angle D. And we did mark that. That's that third angle congruence theorem. Therefore, if we have all of the parts marked congruent in both triangles, then triangle ACD is congruent to CAB by definition of congruent figures. You try. Pause the video and try this one. We're told that this, not triangle, but quadrilateral, FGHJ is congruent to STUV. So F is congruent to S. G, this one, I'm gonna mark it this way, is congruent to T. U and H are congruent, and we can see that they're both marked 90 degrees, and V and J. Find the value of X that makes, find the value of X and the measure of angle G. We know that G and T are congruent to each other, therefore 2x minus 7 equals 103. We'll add 7 to both sides. And divide by 2. We have an x value of 55. When we plug 55 in for x, 2 times 55 is 110. Minus 7 will be 103. So we found the value of x and we found the measure of angle G, which we knew to be 103. In the diagram, QRST is congruent to WXYZ. Find the value of x and y. Again, my suggestion is to mark all the angles that you know to be congruent. Q is congruent to W. So right away, I can set those two expressions equal to each other. 65 equals 5x plus 5. Subtract 5 on both sides. Divide by 5. We'll get the x value to be 12. And let's see what else we can figure out. Let's see. We need to find the value of x, and we need to find the value of y, which is right in here. So this side, wx, here's wx, is congruent to qr, which is here. So we have 6 equals y minus x. Oops. Yeah, and we said x was 12. So I'm just plugging in my x value. I'm going to add 12 to both sides. We'll get a y value of 18.